Over the last couple of videos, we've discussed a lot of the propulsion technologies that are being used by rockets today. However, in order for humanity to become a spacefaring civilization, new technologies will need to be developed. There are many technical difficulties in terms of efficiency and power, which prevent us from being able to travel around our solar system easily, let alone traveling from star to star. So what are some of the technologies that could enable the sci-fi future that many of us have dreamed of?
Helm, Warp 1, engage!
You may have noticed on the chart that we used in our previous videos that many of the technologies there have not yet been discussed. And they just happen to be the ones that give us the right balance between power and efficiency that could enable a really powerful propulsion system. We will see that many of these technologies could potentially be more useful in terms of moving us quickly around the solar system, and could potentially even enable interstellar travel. We begin our journey with the Variable Specific Impulse Magnetoplasma rocket. Wow, that's really a mouthful. It might sound kind of confusing, but actually, it's not much more than a microwave oven. If you've ever left something like sauce in the microwave, you may have noticed that if you left it in there a bit too long, it does create some rather explosive results. Well, rocket engineers noticed that maybe you can use this similar method to heat up some gas and produce some thrust. Instead of using microwaves, the VASIMR rocket uses radio waves in order to ionize and excite gas molecules, eventually turning them into a plasma. This hot gas is then confined and constricted by electric and magnetic fields in order to produce thrust for the rocket. In this way, it's a bit of a cross between a nuclear thermal engine and an ion drive, trying to take the best from both worlds. The VASIMR rocket is able to get higher thrust, like the nuclear thermal rocket, while also getting higher specific impulse, like the ion drive. This would place the VASIMR rocket somewhere here on the specific impulse versus thrust chart. However, this engine runs up against some real issues when taken from paper into the real world. ASTRA is a company that actually managed to build a VASIMR rocket, and it turns out it took a lot more power than they were expecting. In order to generate just 5 newtons of thrust, they needed more than 200 kilonewtons of power. To put that in perspective, that's enough to light up an entire city block. Basically, the only way to get this kind of power on a spacecraft, you basically need a nuclear reactor. Oh, there we are again, requiring nuclear things in order to power our spacecraft. In the end, the VASIMR rocket may inherit the best traits of nuclear thermal propulsion and ion drives, but it also inherits their worst traits as well. If you'd like to learn more about the VASIMR engine, we really recommend that you check out the VX200, which was built by ASTRA. Since a sufficient power source seems to be a recurring problem in terms of advanced and futuristic engine designs, what if we could eliminate the power source altogether? This is the thought pattern that went into a new idea called laser-powered propulsion.
In essence, a sophisticated heat beam which we called a laser.
This idea is essentially a solar sail on steroids. If you'd like to learn more about solar sails, be sure to check out our last video, which covered them in depth. Essentially, with the concept for laser-powered propulsion, you'd have a small spacecraft with a very large sail, and then you could shoot a laser at that sail and propel it towards its destination. The advantage of laser-powered propulsion over simple solar sailing is that you can have the same amount of thrust with a much smaller sail. The sun has a very constant power, but you could theoretically power up the laser shooting at your spacecraft to as high as you wanted. This could potentially give you a lot of mass savings and can potentially allow you to achieve much higher speeds. The key engineering challenges behind this design are to first design a laser which can contain such high powers. It can be set up on ground and can be focused all the way into space where your spacecraft is. Current laser technology is not quite able to perform at the levels that we would need to make this possible, but it could be just over the horizon. Secondly, you would need a very thin material which can withstand the barrage of the laser and still maintain its structural integrity for the duration of a mission. We do already have materials that seem like they could be a good fit for this type of function, so maybe this technology could be just around the corner. This is why the laser-powered proposal by Breakthrough Starshot could be such an interesting idea. Their idea is that they could send a spacecraft all the way to our nearest star just by using this laser-powered device if we had a small enough spacecraft. Be sure to stay tuned with what Breakthrough Starshot is doing next. One of the main issues with laser power propulsion is that they wouldn't be very useful in human applications, simply because there's no way to slow down.
We passed them! Stop this thing! We can't stop. We've got to slow down first.
The laser is really good at accelerating the spacecraft all the way into space and getting it to really, really high speeds that could take it even to another star. But what do you do when you get there? The spacecraft is going at percentages of the speed of light, and there's no way for it to slow down because there's no laser at the other side to shoot at the spacecraft and slow it down. So essentially, laser power propulsion could be good for sending small spacecraft to far off destinations really quickly, but for human applications, it wouldn't be so useful. That is, of course, if the people on the spacecraft don't mind quickly flying by the destination and never seeing it again. Who knows, maybe there's some people like that. So maybe you're feeling a little bit disheartened that we haven't found a technology that could be really used for human space exploration. You might be interested in some of the next technologies that are coming up. One such technology that was even being considered by NASA back in the 1960s is called nuclear pulse propulsion. And the name kind of reveals exactly what it's all about. Essentially, scientists realized that, hey, nuclear explosions are pretty powerful. What if we just kind of use those in order to push our rocket forward?
Right.
Thus, nuclear pulse propulsion was born. With nuclear pulse propulsion, essentially what you do is throw a nuclear bomb behind your rocket, and then you have a special plate which absorbs the shock of the nuclear explosion and pushes your rocket forward. And you'd want to do this constantly over the course of your journey to your destination. Now you might think that nuclear explosions going off behind you every couple of seconds might be a bit of a bumpy ride, but it turns out that rocket scientists were actually working on this back in the 1960s. They were working on a special type of shock plate which would absorb the blast of a nuclear explosion and distribute that force over a couple of seconds as it pushed the rocket forward. There are even some really cool testing footage videos of them testing out this idea with just regular explosives. Unfortunately, like a lot of other nuclear technologies that were being developed in the 1960s, this was also banned. Which kind of makes sense because, on second thought, exploding a bunch of nuclear bombs behind your vehicle doesn't exactly sound like the most safe way to travel through space. It's almost like they didn't really care about the whole radiation thing back then. But don't be disheartened yet. With the advent of safer and safer launch vehicles over the past decades, it could be that we see a return of these nuclear propulsion ideas. Nuclear pulse propulsion actually ends up being a really powerful and efficient way to travel around the solar system, which makes it kind of ideal for human-type applications. If we were to put it onto the specific impulse and thrust chart, it would end up somewhere here. One limitation that will always be on nuclear pulse propulsion, though, is that you will never be able to fire one of these in the atmosphere of the Earth. Obviously, a society where rockets are just throwing out nuclear bombs every couple of seconds and exploding them all over the atmosphere would not necessarily be one you'd want to live in. Well, if you have ambitions to travel to another star, I don't think fission's quite going to cut it for you. You might be looking for something with a little more power, maybe like the power of a sun. It could be that nuclear fusion is your answer.
The power of the sun in the palm of my hand.
Now we're getting really high-tech and hypothetical. There are some theoretical concepts that have been drawn up which would investigate what a fusion rocket would look like. I would recommend looking at Project Daedalus, which did a pretty in-depth analysis of what a spacecraft that was traveling between stars might look like if it was powered by nuclear fusion. Of course, in these applications, it requires what we call cold fusion, which means you have a fusion reaction where you're pushing two atoms together to make really high amounts of energy, just like it is in the sun, but you're doing it without the intense heat and the intense pressure that you would actually have inside the sun, which would be essentially impossible to replicate inside of a rocket engine. But with some clever engineering and some futuristic tricks, it could be that cold fusion could become a reality, in which case, powering a rocket by nuclear fusion would totally make sense. Nuclear fusion propulsion lies somewhere here on the specific impulse to thrust curve. The beauty of this concept is that you can achieve really, really, really high specific impulses, like ones that could potentially make speeds up to 5 to 10% the speed of light totally possible. At these powers and efficiencies, you start to really be able to enable interstellar travel. In fact, if you brought enough fuel with you, you might even be able to get up to like 50 to 75% of the speed of light. At these speeds, you could get to the nearest star in just a little over 5 years. And you wouldn't have the problem that laser power propulsion would have. You could actually slow down when you got to your destination. But there's one more theoretical technology that may be even better than nuclear fusion. That would be antimatter.
Okay.
Now you may think I've really lost my mind. Like, antimatter? What the heck is that? Well, it turns out that antimatter is actually a real thing. At many proton colliders, like the Large Hadron Collider in Switzerland, they've actually made lots and lots of antimatter. So what is it that makes antimatter so special and useful to rockets? Well, it turns out that the most powerful reaction known to man is to take an antimatter particle and combine it with a normal matter particle. When this happens, this completely annihilates the mass of both of the particles and turns them straight into energy. And if you know Einstein's famous formula, E equals mc squared, then you know that small amount of mass gets turned into a lot of energy. So if we're making antimatter in labs today, and we know how powerful it is, why aren't we using it to power our rockets today? Alas, there's one major problem to the whole antimatter production scenario. It turns out that while they do produce antimatter at these colliders around the world, they don't actually make that much of it. The total amount of antimatter produced to date is only 20 nanograms. That's 0.00000000002 kilograms of matter. With so little antimatter produced, there's no way we could power a whole rocket. At least, not a very big one. Maybe one for ants.
What is this?
A center for ants!
In order to produce the quantity of antimatter that we would need to travel to the stars, it would take us literally tens of billions of years of these colliders running at full speed, producing antimatter. But hey, maybe in the future, humanity will figure out ways that we can produce antimatter faster and more efficiently. Here at ASTRA, we're trying to do our part to help further develop propulsion technologies for our future. Many of us have the vision of one day seeing humanity amongst the stars. If you like this video, please be sure to give a like and subscribe. And remember to keep expanding your horizons.